Good morning everyone, hope you all safe with a good health. With you Ms. Zina Al-Badri, physics teacher for grade 9. Today we will talk about the nature of light. Wave and particles. It is difficult to describe all the properties of light with a single model. The two most common models describing light as a wave are stream of particles. Okay, light produces interference pattern as water waves do. So the light wave is still used today to explain many of the basic properties of light and light's behaviors. We said last time that we have two types of wave: transverse wave and longitudinal wave. Transverse waves that don't require a medium in which to travel. Transverse wave described by their amplitude, wavelength, and frequency. Okay, so to describe the transverse wave, we need to describe the transverse wave. We need to know the amplitude, wavelength, and frequency. Light waves are also called electromagnetic wave because they consist of changing electric energy and magnetic field. Okay, so light wave change electric and magnetic field. Okay, longitudinal wave need medium to transfer, but the transverse wave doesn't need medium to transfer. The particle model of the light can explain some effects that the wave model cannot explain. Red light cannot knock electrons off the metal plate. Blue light can knock electrons off the metal plate. The wave model of light cannot explain this phenomena. Okay, so we have phenomena can't be described by the light, and phenomena can be described by the light. So the wave model of light cannot explain the phenomena of red and blue light. Okay, in the particles model of light, beam of light is a packet of particles. We call these photons. Not like ordinary matter, no mass, they are little bundles of energy. So the photon, not like the matter, doesn't have a mass. They are little bundles of energy. The model of light used depend on the situation. Wave model can explain interference. Particle models explain how light can travel across empty space without a medium. So we have two models to describe the light. Wave model can explain interference. Particle model explain how light can travel across empty spaces without a medium. Okay, we know that the wave of light is transverse wave, which doesn't need a medium to transfer. Okay, so the particle model explain how light can travel across empty spaces without a medium. The energy of light is proportional to the frequency of the electromagnetic wave. So, the energy of light is proportional with the frequency of the electromagnetic wave. The speed of light depends on the medium. So, the speed of light in air is 3 by 10 over 8 meters per second. When light passes through a medium such as the air, water, and glass, it travels slower than it does in a vacuum. So, the speed of light in a medium is slower than the speed of light in vacuum. The speed of light in medium is slower than the speed of light in vacuum. Okay, the brightness of the light depends on the intensity. Intensity depends on the number of the photons per second, or the power of light that pass through a certain area of space. Okay, did you see? Decreases. A distance from the light source increases. So the intensity depends on the number of the photon per second, the power of light, which pass in 1 second. Electromagnetic spectrum consists of wave at all possible energy, frequency, and wavelengths. Okay, so electromagnetic spectrum, it consists of wave at all possible energy, frequency, and wavelengths. Like the radio wave, microwaves, infrared, ultraviolet, X-ray, gamma ray, all of this type of wave which each one has a different wavelength and a different frequency. Okay, it's shape of the electromagnetic spectrum, different wavelengths, different frequencies. Every object reflects some light and absorbs some light. It is useful to another model for light, the light ray, to describe reflection, refraction, and many other ways light behaves. So, what is the properties of light? Light can pass, can transmit, can reflect, can refract, can separate. A light ray is an imaginary line running in the direction that the light travels or passes of photons. Okay? Reflection and color. So we will talk about reflection and refraction and the difference between them. Reflection of light. Rough surface reflect light ray in many directions. Smooth surface reflect light ray in one direction. We have something to describe this phenomena. We call it law of reflection. The angle of the light reflected off the surface, called the angle of reflection, is the same as the angle of the light ray striking the surface. We call it the angle of incidence. Okay? Both of these angles are measured from the line that is perpendicular to the surface at the point where the light hits the surface. We call it normal. That you see, this is the normal, and this is the incidence light ray, and this is the reflected ray. This in a smooth surface, but in rough surface, that you see, the two lights, the incidence light ray and reflected, doesn't be equal in a rough surface. That you see, incidence ray, normal, and perpendicular light, theta incidence, theta r, theta reflected. Both of them are equal. Both of them are equal in a smooth surface. A mirror reflects light as described by the law of reflection, and this light reaches your eyes. The type of image you perceive depends on the type of mirror. Okay, so we have two types of mirror: plane mirror and convex or concave mirror. Okay, so we have two types of image: real image or virtual image. So the type of image depends on the type of mirror. Virtual image, an image from which light rays appear to diverge even though they are not actually focused there, cannot be projected on a screen. Real image, an image that is formed by the intersection of light ray, can be projected on a screen. Can be projected on a screen. Okay. Most mirrors are made by coating a piece of glass with a layer of metal. The glass provides the smooth surface necessary for a good reflection and protect the metal from becoming scratching. Okay. A solution containing a silver nitrate is poured onto the glass, and deposit of the silver adheres to the glass. The remaining of the solution are poured off and the glass is dried. The silver surface, the back of the mirror, is then coated with a protective substance such as any material, okay, to keep the silver from being rubbed off or scratches. It is this, by the way, how to make a mirror. Okay, this is a plane mirror. The image, how the distance between the image and the mirror equal the distance between the body and the mirror. Okay, this is for the plane mirror. In a plane mirror, there you see the image. Curved mirror. We have two types of curved mirror. We say that they are concave and convex. And imagine created or destroyed. Convex image is smaller passenger side mirror. Here you see, this is a convex mirror. Did you see? This is this shape for concave and convex a mirror, like the spoon. Okay, did you see? Convenience store mirror are convex. Convex mirror will produce upright, visual images that are smaller than the object. Their benefit is that they allow you to see more area in the reflection. Concave mirror image, it will be large. Makeup mirror are concave. Concave mirror will produce upright, magnified visual image if the object is between the focal point and the mirror. Scene color, the color that you perceive depend on the wavelengths of visible light that reach your eyes. Objects have the color of the wavelengths they reflect, like the green, like the white, like the black. Green leaf reflected green wavelengths and absorb the other wavelengths. White reflect all wavelengths. Black absorb all the color or all wavelengths of the color. Okay, so the white, why we can see the white light with the white color? Because it make a reflection for all wavelengths. So when all the color, all 7 spectrum color are collected or mixed together, it gives us a white light.